Why is problem solving important? The importance of problem solving in learning mathematics comes from the belief that mathematics is primarily about reasoning, not memorization. Problem solving allows you to develop understanding and explain the processes used to arrive at solutions rather than remembering and applying a set of procedures. Problem solving in mathematics supports the development of the ability to think creatively, critically, and logically, the ability to structure and organize, the ability to process information, enjoyment of an intellectual challenge, the skills to solve problems that help you to investigate and understand the world. If you want to solve a word problem, you need to follow the solving strategies. Read the problem. Read it twice, thrice, until you understand the concept of the problem. Make sure all the words and ideas are understood. Identify what you are looking for. Name what you are looking for. Choose a variable to represent that quantity. Translate into an equation. It may be helpful to restate the problem in one sentence with all the important information. Then translate the English sentence into an algebraic equation. Solve the equation using algebraic techniques. Check the answer in the problem and make sure it makes sense. Answer the question with complete sentence. Let us try example number 1. If the difference between a number and its reciprocal is 24 over 5, find the number. After we read and analyze the problem, let us name what we are looking for. So meaning, we're going to make now a representation of the problem. Let x be the required number and 1 over x be its reciprocal. If x is the number and 1 over x is the reciprocal of the number, so therefore, the equation of the problem is x minus 1 over x equals 24 over 5. Why? Because of the word difference between a number and its reciprocal is 24 over 5. And to solve this kind of equation, we need to identify or determine what is the least common denominator of the equation. And the LCD is 5x. This time, we're going to multiply both sides by the least common denominator. So that's why it becomes 5x times the quantity of x minus 1 over x equals the quantity of 24 over 5 multiplied by 5x. After we multiply both members of the equation by 5x, then the equation becomes 5x squared minus 5 equals 24x. After we transform the resulting equation into standard form, so this time, we're going to choose now the best method to solve for the value of the unknown, and that is by factoring. The factored form of the equation 5x squared minus 24x minus 5 equals 0 is the quantity of 5x plus 1 times the quantity of x minus 5 equals 0. Why? Because the outer product plus the inner product satisfy to the middle term of the quadratic equation. So this time we're going to apply now the zero factors property, meaning we're going to equate both factors equal to 0. So the equation becomes 5x plus 1 equals 0 and x minus 5 equals 0. 5x plus 1 equals 0 and x minus 5 equals 0 are both linear equation. So meaning 5x plus 1 equals 0 equals negative 1/5 and x minus 5 equals 0 equals 5. After we solve the equation and get the value of the unknown term, so this time, we're going to replace it to the original equation to check if the obtained values satisfy to the equation. We're going to replace first x equals 5 and then followed by x equals negative 1/5. After we replace the value x equals 5 and x equals negative 1/5 to the original equation, we saw that both values satisfy to the equation. So therefore, the number is 5 or negative 1/5. If the number is 5, then its reciprocal is 1/5. And if the number is negative 1/5, then its reciprocal is negative 5. Let us try example number 2. A rectangular garden has an area of 14 square meters and a perimeter of 18 meters. Find the dimension of the rectangular garden. Like example number 1, we're going to make now a representation. Let L equals length and W equals width. If L is the length of the rectangle and W is the width, so therefore, the area of the rectangular garden is L times W equals 14, and the perimeter is 2L plus 2W equals 18. This time, we're going to simplify equation number 2, and that is 2L plus 2W equals 18. We're going to divide each term by 2, and the equation becomes L plus W equals 9. We're going to use now the method of substitution and use L equals 9 minus W and replace it to equation number 1, LW equals 14. And the equation become the quantity of 9 minus W times the quantity of W equals 14. Why? Because instead of L, we use 9 minus W, and after we simplify, the equation become 9W minus W squared equals 14. And to solve this equation, 9W minus W squared equals 14, we're going to use factoring, meaning we're going to change or transform the equation into standard form. So it becomes W squared minus 9W plus 14 equals 0. The factored form of the quadratic W squared minus 9W plus 14 equals 0 is the quantity of W minus 7 times the quantity of W minus 2 equals 0. By applying the zero factor theorem, the equation becomes W minus 7 equals 0 and W minus 2 equals 0, and the value of W equals 7 and the other value equals 2. After we get the value of the variable, which is 7 and 2, and replace it to the original equation, length times W equals 14 and 2L plus 2W equals 18, then we can say that the dimension of the rectangular garden or width equals 2 meters and the length equals 7 meters. Let us now proceed to example number 3. Within 11 years, the age of Peter will be half the square of the age he was 13 years ago. Calculate the current age of Peter. Let x be the current age of Peter. So meaning, age of Peter 13 years ago is x minus 13, and age within 11 years is x plus 11. The equation of the problem is x plus 11 equals the quantity of x minus 13 raised to second power all over 2. Why? Because of the sentence, within 11 years, the age of Peter will be half the square of the age he was 13 years ago. To simplify this equation, we need to multiply both members of the equation by 2. So that's why it becomes 2 times the quantity of x plus 11 equals the quantity of x minus 13 squared over 2 times 2. And the equation, after we simplify, become 2x plus 22 equals the quantity of x minus 13 raised to second power. This time, we're going to simplify now the right member of the equation. We're going to expand x minus 13 raised to second power. And the equation become 2x plus 22 equals x squared minus 26x plus 169. So this time, we're going to combine 2x and negative 26x. And then the equation become x squared minus 28x plus 147 equals 0. We're going to solve x squared minus 28x plus 147 equals 0 by factoring. And the factored form is the quantity of x minus 21 times the quantity of x minus 7 equals 0. And by applying now the zero factor theorem, then the equation becomes x minus 21 equals 0 and x minus 7 equals 0, and the value of x equals 21 and the other value is 7. And from the given statement on the problem, we can say that 7 cannot be the age of Peter. Why? Because if we're going to use 7 as the age of Peter, 13 years ago, the age of Peter will become negative. So, therefore, the current age of Peter is 21 years old. That's all. Thank you for watching and God bless everyone.